Exercise 1.1. Question number 1. Express each number as a product of its prime factors. First one, 140. So here 140, when you are going to see, it divides with 2 here, 70, and again with 2 we get 35 here, again with 5 we get 7 here. So in this way we can simplify the number. So when you are going to see the factors here, that will be 2 into 5 into 7. And when you are going to see the factors, prime factors, it can be written as 2 to the power of 2 into 5 to the power of 1 into 7 to the power of 1. So this will be the product of prime factors of number 140 here. Next 156. So 156, when you are going to see, so we divide with 2, we get 78 here. We divide with 2, we get 39 here. We divide with 3, we get 13 here. And it can be written as 2 into 3 into 13. And powers, when you are going to keep 2 to the power of 2 into 3 to the power of 1 into 13 to the power of 1 here. Next number 3825. So 3825, when you are going to see, it divides with 5 here. We get 765. We divide with 5 here. We get 153. Again, it divides with 3 number. So we get 51 here. Again with 3, we get 17 here. So when you are going to see the factors, it will be like 3 into 3 into 5 into 5 into 17. So writing in the ascending order of the factors. So it will be easy to understand. So when you are going to keep the powers 3 to the power of 2, 5 to the power of 2 into 17 to the power of 1. So this is the product of prime factors of number 3825. Fourth one, 5005. 5005. So now this number we divide with 5 here. So 1001. Again it divides with 11 here. So when you divide it, we get 91 here. Again it divides with 13, we get 7 here. So when you are going to write the factors, it will be 5 into 7 into 11 into 13. So you want to keep powers, so 5 to the power of 1 into 7 to the power of 1 into 11 to the power of 1 into 13 to the power of 1, in this way. Next number 7429. So 7429. So here when you are going to see, it doesn't divide with 2, 3, 5. So after seeing all numbers, we land at number 17 here. We get 737 here. And after that, this number divides with 19, we get 23 here. So the factors will be 17 into 19 into 23. So this will be the answer. Question number 2. Find the LCM and HCF of the following pairs of integers and verify that LCM into HCF equal to product of two numbers. So the numbers given is 26 and 91. So first we are going to simplify and find out the LCM and HCF of these two numbers. So 26 when you are going to see, it divides with 2 here and we get 13. And here the factors are 2 into 13 here. And after that 91 when you are going to see, 91. So here it divides with 7. So here 13. Then 7 into 13. So we know that LCM is a product of greatest power of prime factors here, and HCF we know product of smallest power of each common prime factors here. So here when you are going to see, the common factor is 13 here. The common factor is 13 here. So HCF will be 13 here. And LCM when you are going to see, LCM when you are going to see, it is the product of greatest power of each factor. So each factor we are going to multiply here. That means 2 into 7 into 13. So this is the factors. So when you are going to multiply, we get 182 here. So this is the LCM and this is the HCF here. And in the question they asked verify. So verify when you are going to see LCM into HCF. LCM into HCF is equal to product of two numbers or not. So HCF we know that is 13 into 182, and product of two numbers, that means 26 into 91. So when you are going to multiply this, we get 2366, and when you multiply this, we get 2366. So these two numbers are equal here. Next 510 and 92 here. So 510 when you are going to see, divides with 2, we get 255 here. Divides with 5 here, we get 51 here. Again 3, we get 17 here. So the factors are 2 into 3 into 5 into 17 here. Next number when you see 92 here, 92, it divides with 46. Again it divides with 23. 2 into 23. So here when you are going to see HCF here, HCF when you are going to see the product of smallest power of each of a common prime number. Common here when you are going to see, common is 2 here. The common is 2 here. So the HCF will be 2. And LCM when you are going to see, LCM means we are going to see product of the greatest power of prime factors each. That means greatest power 2, we get here 2 to the power of 2, and here 3 to the power of 1, here 5 to the power of 1, here 17 to the power of 1, here 23 to the power of 1 here. So when you multiply this, we get 2, 3, 4, 6, 0 here. So HCF is 2, LCM is 2, 3, 4, 6, 0. And we are going to verify it. Verify what? LCM into HCF equal to product of two numbers or not. That means here we know LCM 2, 3, 4, 6, 0 and into 2. And product of two numbers, that means 510 into 92. That means when you multiply this, we get 46920, and when you multiply this we get 46920. That means both are equal here. Next, third number 336 and 54. Now 336, when you are going to see, divides with 2, we get 168. Divides with 2, we get 84. Again divides with 2, we get 42. Divides with 2, we get 21. And here divides with 3, we get 7 here. So we get factors 2 into 2 into 2 into 2 into 3 into 7 here. And next number, when you see 54 here, 54 when you divide, that means 2, it will 27. Again here 3, here 9, here 3, here 3. So we get here 2 into 3 into 3 into 3 here. So now HCF, when you are going to see, HCF means the product of smallest common factors here. So smallest common factors when you are going to see, so here it is 2 is common and 3 is common. That means 2 into 3, so that will be 6 here. And LCM, when you are going to see, product of greatest power of each prime factor. That means 2 is there, then greatest power is 2 to the power of 4 here. So this will be 2 to the power of 4 into 3 to the power of 1 into 7 to the power of 1. And this will be 2 to the power of 1 into 3 to the power of 3. So now 3 number, when you see, 3 to the power of 3. And next 7 number, when you see, 7 to the power of 1. So when you are going to multiply this, we get 3024 here. So now we see the verification part, LCM into HCF, when you are going to see, so that will be the product of two numbers or not. So LCM, we know 3024 into 6, and product of two numbers, that means 336 into 54 here. So when you multiply this, we get 18144, and 336 into 54, we get 18144. So these two numbers are equal here. Question number 3. Find the LCM and HCF of the following integers by applying the prime factorization method. First one, 12, 15, 21. So here we take the factors of number 12 here. So it divides with 2. So 6. Again 2, we get 3. So here the factors are 2 into 2 into 3. It can be written as 2 to the power of 2 into 3 here. So number 15, when you are going to take 15, it divides with 3, we get 5 here. So now the factors will be 3 into 5 here. The next number 21, when you are going to see, so it will be 3 and here 7. So that will be 3 into 7 here. So now numbers, when you are going to see the HCF and LCM. So numbers 2, when you are going to 12, when you are going to see, that is 2 to the power of 2 into 3. 15, when you are going to see, that will be 3 to the power 3 into 5. 21, when you are going to see, so that will be 3 into 7. So HCF, we know that will be the common factor, which is smallest here. Common factor, when you are going to say, it is 3 here. So this will be the common factor 3. So 3 is common. So HCF will be 3 here. LCM, when you are going to see the greatest power, we are going to see of each factor. That means 2 number is 2 to the power of 2 into 3 number, that is 3 to the power of 1, 5 number 5 to the power of 1, 7 number, that means 7 to the power of 1. So when you multiply it, we get 420 here. So here HCF is 3 here, LCM is 420 here. Next second, 17, 12, 29. So here when you see the number 17, the factors will be 1 into 17. So it is a prime number, so we are writing 1 into 17. 23, when you are going to see, it will be 1 into 23. And 29, when you are going to see, it is 1 into 29. So HCF, when you are going to see here, HCF, we know the common factor we are going to see, so that will be 1 here common. So here HCF will be 1. And LCM, when you are going to see the product of greatest power factors, that means 17 to the power of 1 into 23 to the power of 1 into 29 to the power of 1 here. So when you multiply this, we get 11339 here. So this is the LCM and this is the HCF. Next third, 8, 9, 25. So 8 number, when you are going to see, divides with 2, here 4, here 2, here 2. So that will be 2 into 2 into 2. So that will be 2 to the power of 3 here. Next 9. 9, when you are going to see, divides with 3, here 3. And it will be 3 into 3. So the factors will be 3 to the power of 2 here. Next number 25. So it divides with 5. 5. So that will be 5 into 5. So it is 5 to the power of 2. So now when you are going to see the numbers 8, 9, 25, finding the LCM and HCF. So here 2 into 2 into 2, here 3 into 3, here 5 into 5. So HCF means we are going to see the common factor here. So there is no common here, 2, 3, 5, no common. So we are going to take 1 as factor. When you multiply with 1, we get 1 is the factor, common thing. So HCF will be 1 here. And LCM, when you are going to see the greatest power, we are going to see of each number, that means 2 to the power of 4, here 3 to the power of 2, here 5 to the power of 2. So that means 2 to the power of 4 into 3 to the power of 2 into 5 to the power of 2. So when you are going to multiply this, we get 1800. So this is the LCM and 1 is the HCF. Question number 4. Given HCF of 2 numbers is 9 and find the LCM here. So the 2 numbers given is 306 and 657. So we know that HCF into LCM is equal to product of 2 numbers here. Product of two numbers here. So the given data here, HCF is given, which is 9, and LCM we are going to find out. And the product of two numbers given, that is one number is 306 and another number is 657 here. So here by simplification, LCM equal to 306 into 657 by 9 here. That will be 201042 by 9. That will be, after simplification, we get 22338 here. Question number 5. Check whether 6 to the power of n can end with the digit 0 for any natural number n. So here when you are going to say 6 to the power of n number, so n can be 1, 2, 3, so on. That means any natural number here. So if you are going to assume that suppose it is 6 to the power of 1, so the answer will be 6 here. If it is 6 to the power of 2, then answer will be 36. And if it is 6 to the power of 3, then answer will be 216. So in this way, when you are going to see the answer we get, and the last digit when you are going to see ends with 666 here. So when you are going to keep natural number in place of n, the number we are getting, the last digit will not be 0 here. So this is the numbers we get here. So when you are going to see how the number will get digit 0, means if you are going to see any number, x number, when you multiply with 10, we get here x 10. So that means the last digit will be 0 here when a number is multiplying with 10 here. But 10 factors are 2 into 5. 10 factors are 2 into 5. If a number is having factors 2 into 5 or 2 and 5, then we can say that this number will end with last digit 0 here. So here we can write if the numbers ends with digit 0, it should have factors 2 and 5 here. But the number when you see 6 number, when you are going to say, it is having only 2 number, but not number 5 here. So therefore we can say that 6 to the power of n does not end with digit 0 here. Question number 6. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. So here what do you mean by composite numbers here? In the sense, the composite numbers means having more than 2 factors, we say it as composite numbers here. If you are having only 2 factors, then we say it as prime numbers here. So suppose 2 is there, only 2 factors, 1 and the number itself. So these are the 2 factors. So we say it as prime number. Now 7 is there, suppose, then 1 and number itself. And 19 is there, we say 1 and 19 itself. So these are prime numbers which are having 2 factors. But the number which is having more than 2 factors, then we say it as composite numbers. The 2 numbers have given here in the question, and we are going to simplify and find the number here first. So 2 numbers we will get. After that, these numbers are having more than 2 factors or not, we are going to check. If it is having more than 2 factors, then we can conclude that the numbers are composite numbers. If only two factors are there, then we conclude that it is not a composite number, or it will be a prime number. So the number, suppose 7 into 7 into 11 into 13 plus 13, when you are going to see. So here multiplying, simplifying, that means taking the 13 number common, we get 7 into 11 into 1 plus 1 here. So after that 13 into 77 plus 1, so that will be 13 into 78. So when you multiply this, we get 1014 here. In the same way, another number, that is 7654321 plus 5, we will check. That means 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 here. So when you multiply this, that means taking 5 common or multiply all these things, add 5, is same here. So taking 5 common, we get 7 into 6 into 4 into 3 into 2 into 1 plus 1 here. So that means 5 into, so when you multiply all these things, we get 1008 plus 1. So that will be 5 into 1009, and 5 into 1009, we get 5045 here. So these are the two numbers we are going to see here. Now these two numbers, one number is 1014, another number is 5045. So now these two numbers, when you are going to see, we are going to see the factors now. So one is the common factor, and another, the same number, is another factor. So apart from these two, we get another two numbers, that is 13 and 78 also. So these two numbers also factors of 1014. Now 5045, 1 and same number 5045. Apart from this, what are the factors? That means 5 is one factor and 1009 is another factor. So now we conclude that a number which is having more than two factors, we say it as composite number. That means here 1014 having more than two factors, 5045 having more than two factors. Then we conclude that therefore the two numbers are composite numbers. The two numbers are composite numbers. If you are going to see the numbers which is having only two factors, then we say it as a prime number here. Question number 7. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? So here we are going to see a circular path, and let it be the starting point. So Sonia is moving here. So Sonia is taking 18 minutes, and another person, Ravi, he is taking 12 minutes here. So at what time they will reach here means we are going to take the at what time they will reach here. So here how we take the common by prime factorization method. Suppose 18 we are going to take, so we divides with 2, it is 9, here 3, here 3. So here when you are going to see 2 to the power of 1 into 3 to the power of 2 here. Next 12 when you are going to see 12, here 2, here 6, here 2, here 3. So 2 to the power of 2 into 3 to the power of 1 here. So when you are going to see the LCM here, so LCM when you are going to see, so we are going to take the highest power of each factor and we are going to multiply it. That means highest power of 2 will be 2 to the power of 2 here, and 3 when you are going to say 3 to the power of 2 here. And here we are going to find out when you simplify it, so 4 into 9, so that will be 36 here. So at 36 minutes they both meet, that is the answer.